Good day, good day, learners. Godfrey is here. I'm here to take you through the National Senior Certificate Examination for 2023, Paper 1. As I finish Paper 1, we shall be starting Paper 2 very soon. You'll be waiting, you will get Paper 2 very soon. You can see 150 marks, 3 hours. We'll start from there. And here we come. I'm not going to take you through the instructions, but I'll just take you through directly to the questions. Question 1 is climatology. Various options are provided as possible answers to the following questions. Choose the answer and write only letters under that. So what do we do? We are given a map here. We need to start by interpreting that map. The map you have here, we have got high pressure cell here, we have got which is in the center, which we know that if we have high pressure cell in the interior, which season is depicted? It's a winter season. Okay, let's quickly go to the questions. 1.1.1. The season represented in the synoptic weather map is obviously, like I said, it's winter. So there we quickly go, and the answer is D. Okay, so we go down 1.2. The isobaric interval of the isobars on the synoptic weather map is thus in hectopascal. We come here. We're looking at these isobars. These are the isobars. So when you look at this one, this is a high pressure. And this is 1024. Okay. So this is 1020. That means as you're getting away from the high pressure, it's decreasing. But it's decreasing with what? 4. So that means A is going to be 1020 minus 4, which becomes 16. So 1016. So 1016, when you look at the various options that are here, but they say the isobaric interval. So the interval, that is the difference between the different isobars, is 4. So the answer becomes B. Okay. We go down. The air pressure reading at A, the air pressure reading at A, the air pressure reading at A, the air pressure reading at A is that hectopascal. Obviously, I've just told you that A is what? Minus 4, because this is 1024, 1024, 1020, so that minus 4, it becomes 1016. So 1016 is that option there. It's there, and therefore it is A. Okay. We go forward. Point 4. The dew point temperature indicated at the weather station B is dash degrees centigrade. We go to weather station B. Weather station B, the dew point. Of course, this one on top is the air temperature. The one down is the dew point temperature, which is 1. So the answer is 1. And when you check the options that are given there, 1 is there, and which is C. So here is C. The weather station around the interior high pressure cell show clear skies due to dash A, and the anti-clockwise rotation around results into this kind of points. So here we're looking at 1.5. And then let us look at the various options. 1 is saying subsidizing. Obviously, it's a high pressure. A is subsidizing. That option must be there. That option is there. Also, we have rising. Of course, it can't be subsidizing and rising. That one is out. So when we look at our options, wherever there is 2 is wrong. So that means this one is obviously wrong. Okay. So C is obviously wrong. We go to another one. Southwesterly direction. Or southeasterly direction. So there is Roman number 3 there. And when you look at Roman number 3, it can't be southeasterly when you look at this weather station. You go back here, and you check. If you like it, is it southeasterly? No, it is not easterly. We go back down there. Then we say, oh, that of course, wherever there is 3, it's also wrong. So this one is wrong. Okay. This one is also wrong because there is 3. This one is also wrong. Which option do we have? We only have option B, whereby northwesterly and subsidizing. And therefore, the answer here is B. Okay. We go. We have a diagram here that shows. So we are going to use this diagram to answer 1.16 and 1.18. So when we go down here, we're looking at the map of South Africa. We have with the the low pressure system here, which is the negative cyclone, and the anticyclone here on this other side. The first question is CC. So this and this is what? But you can see it's a high pressure. So because this is a high pressure, this becomes what? Raging. So an elongated high pressure is raging. So the answer is A. Okay. 1.1.7, the high pressure cell D will cause weather system E to move in that direction. Which direction is that? So that 1.7, obviously the answer is B. Okay. So here we say D. So the weather condition at this station F, F is here. What is the weather condition? So the weather condition here is which one? Go down and we say air temperature is 8. Let's look at that air station. Air temperature is the atmosphere temperature at that station. Is it 8? No. The atmosphere temperature is 14. So meaning that 8 is number, where we have 8 is number 1. So in these options, wherever there is 1 is wrong. So this one is wrong and this one is wrong. Okay? So we are remaining with those two. Cloud cover is 4/8, which is a half. And therefore, when you look at the station model, it is a half. Therefore, do we have that 2 somewhere? So it is on this and on this. So we are looking for the other option that makes it very right. Southwesterly winds. Southwesterly winds. Obviously, these winds are southwesterly. When you look at it, you come here, it's southwestern direction. This is southwestern direction. So that obviously makes it. Wind speed knot is 5. This one is not 5, it's 10. So that means wherever there is 5 is wrong. So where is 5? 5 is here. So the only option is B. So right there, B. Okay, we'll go forward. Refer to this valley climate. We have the valley climate here. What we need to do, this is a cold plateau. Here we have the shadow zone. We have trees here. We can see cold air of the drainage. You can see crop farming here. And they say south and this is north. That means this slope here is north facing. This slope here is south facing. Okay, and they show us temperatures. Minus. So here, actually here B is higher than up and low, meaning that cold, cool, hotter, or warmer. Okay, so we go down there, see the questions. So we are using this to answer this question. So 1.2.1, the direction in which the slope faces in relation to the insolation. Yes, that is Z, which is Z here. The sketch represents the valley, which hemisphere? The hemisphere obviously is southern hemisphere. Why? Because the slope here is warmer than the slope. So the south-facing slope is warmer than, sorry, the north-facing slope is warmer than the south-facing slope, which makes it the southern hemisphere. So here is why. The next question is, dash wind occurs due to terrestrial radiation. Which one? It can't be anabatic because terrestrial radiation mainly happens late in the night. So why answers there? So 1.24, a temperature inversion occurs between A and B due to dash and or temperature and height. Obviously, the answer here is Z, which increases. Okay, temperature increases. So 1.24 is Z. 1.25, the form of precipitation that could occur at X. Here, it's very cold here, so you don't expect dew. It was only going to be frost. So Z is there also 1.25. 1.26, fog, dash fog may form in the valley in the clear and calm nights. Obviously, that is a radiation fog. Okay. 1.27, the northern side of the valley is covered with trees because the answer is Z, because of low evaporation. Remember, trees have cool environment, or they bring cool conditions. And there's less sun on that side. We go to the next question. The next question is a text. The text given here is the 2 cold fronts to hit Western Cape this weekend. So we have the date here, the 10th of June, 2022. And then they show us that according to South African weather, 2 cold fronts are expected to bring rain, strong winds, high waves, and significant drop in temperatures in South Africa. The first cold front is expected to hit the Western Cape on Sunday evening, 12 June, ahead of the first cold front. Okay. So they say strong northwesterly to westerly winds between 10 to 60 kilometers per hour, gusting up to 80 to 70 kilometers per hour. So are expected over the southern part of the Northern Cape and the interior of Western Eastern Cape from Sunday. So the second cold front is expected to reach Western Cape by Monday evening, which is the 13th. You can see from 10th to the 13th. So bringing that continually high amount of rainfall, okay, etc. when you continue reading. So the first question is, which season do the cold front mentioned above influence Western Cape? When you look at the text, there are months that are given there, which indicates June. June is which month in Southern Africa? It's winter. Therefore, the season here is winter. Give evidence. The evidence is that the month given the text is winter. The June month. The June month. Okay. Then why do the cold fronts have a greater impact on the Western Cape during this season? Why on Western Cape during this season of winter? We must understand that this system moves with the movement of the ITCZ. So when the ITCZ is above the tropical or overhead the tropical Cancer, which is the northern hemisphere, it is winter in the southern hemisphere. So here we are going to say that because the ITCZ shifts, northwards, hence the system, hence the cold front as well, okay, following. Okay, so when the system moves northwards, the cold front also falls northwards and reaching Western Cape, which is the southern hemisphere. Okay, the change in the wind direction mentioned in the extract is what? Since this is southern hemisphere, we take backing. Okay, so the answer here is backing. Give a reason for your answer. Give a reason from the extract for your answer. It is given the extract somewhere. When you go back to the extract, they say the wind direction is associated with the cold front in the southern. No, it's not that one. And say somewhere they say that wind direction associated with the cold front will change from northwest to southwest. Okay, the wind direction associated with the cold front will change. That means the extract is here. Change from southwest to northwest, meaning that there is change in direction. So that answers this question. Okay, and that is the last paragraph. So this last paragraph here answers this question. So in the paragraph of 8 lines, suggests the positive and negative. We are talking about the positive and negative impact of heavy rains associated with the cold front on physical environment. They need the physical environment. So the positive one, I will start with positive. Under positive, which I'll say it clears or cleans the atmosphere. Remember, when it rains, if the environment has been dirty, having toxic or those gases that are not right, when it rains, they will be brought down from the atmosphere, in that the air that is in the atmosphere is going to be clean. That is number one. Number two, another positive impact, that because it rains, this rain is going to be very important for the growth of vegetation. Okay, rain favors the growth of vegetation. Favors the growth of vegetation. Those are all positive. So under the negative one, let's say the negative, we shall have soil erosion. So, okay, let me say heavy rains, I would say say that heavy rains contribute to soil erosion, which is a negative effect. Okay. Then we can have another point here, and we say it also causes flooding. Causes flooding. Then you can also look at soil erosion coming because of heavy rainfall, which means it makes soils infertile because it will wash away the topsoil, which is infertile. But remember, I want you to let learners that all these ones are positive and negative. Therefore, I would like you to write them in a paragraph format. So you write them in a paragraph format. Remember, when you're writing a paragraph, it must be a statement that is making sense. So you make sure that it's a statement. You don't bullet. Please don't bullet, you write it in a paragraph format. Okay, we go to 1.4. 1.4 is an infograph which is showing the tropical cyclone. Okay, and then when you look at the diagram here, it clearly indicates that this is the center, which is the eye. Here are the eye walls, and you can see the cumulonimbus clouds here on the sides. Here air is rising, here air is descending. You can see the kilometers away from the center. So we have the graph associated with the tropical cyclone here. They're showing the air temperature and the wind speed. This is ahead of the eye. This is in the eye. So we also have the isobaric representation of the tropical cyclone, and we have a dangerous quadrant on this side. We have the symbol of a tropical cyclone there that can also tell us the hemisphere. You know very well if this one is here, it tells us a lot about the hemisphere. If the symbol is like that, it also tells us about the hemisphere. If even the diagram, the arrows are like that, it also tells us about the hemisphere, which is the southern hemisphere. But we shall see as we proceed with the questions. Question 1 says, what evidence indicates that the tropical cyclone developed is in the southern hemisphere? You see, learners, if you first interpret the diagrams, it becomes easier for you to get the answers. See, by just interpreting the diagram, I would answer all the questions before even I look at the questions. However, let's say the first evidence that is in southern hemisphere is that air rotates clockwise. Okay, clockwise rotation of air, okay, into the low pressure system. Number 2, we can also look at the location of the dangerous quadrant. The dangerous quadrant is located in the southwest direction. So the dangerous quadrant is in the southwest. Okay, in the southwest. All right. We can proceed. Give 2 reasons. Give 2 reasons. But here is 1 mark. So don't mind, you can write 1 and get all your marks. Give your mark, get a full mark. Okay. Give 2 reasons from the infograph that indicate that the tropical cyclone is in a mature stage. What reason do we have to say that this tropical cyclone that we have here is in a mature stage? The first reason that we are going to give there that is in a mature stage is that the eye is visible. So we say well-developed eye. Okay? Remember, mind the mark allocation is 2 times 1. So there should be 2 points. Okay? Then we can also look at the pressure, the air pressure. Air pressure is below 1,000 MBs. Okay? The air pressure is below 1,000 MBs. Okay, so all those ones are evidence. You can give other evidence, the eye is well developed. Then you can also look at from the very infograph, the speed. But because here it is indicated, actually, you look at the area covered by look at this one. It covers between 500 kilometers and 450 kilometers. So it has covered a wider area, which means it is in its mature stage where it is running at a rapid speed. So you can also give another evidence, the system covers a wider area. Covers a wider area. From 450 to 500 kilometers. That is a bigger area. Okay, give a reason for your answer. But before we reach the reason for your answer, they said, how did the descending A at A influence the cloud cover in the eye? First of all, how means a way, a method. How is it influencing the cloud cover? Here we are going to say that the descending A, that means if A descends, what happens? If A descends, it simply means no no condensation taking place, no condensation. As air descends, there will be no condensation taking place. And therefore, if there is no condensation, it simply means there will be no dew point reached. That means there is no dew point reached. No dew point reached. And that influences what we call the clear skies that exist in the center of the eye. Okay, then give a reason for your answer. Give a reason for your answer. We are looking at 1.4.4. Give a reason for your answer. Okay, the reason is that it influences, okay, this one influences the clear skies. Give a reason for your answer. We shall say no dew point reached. Dew point reached. Hence, clear. No dew point reached. That's why we can have clear skies. All right. Then proceed 1.45. 1.45, they say, what is the relationship between the wind speed and the air temperature as indicated in the graph? We go to the graph. Here we can see the increase in what? Here it shows what happens here. That is, as the height changes, look at where the air temperature is, the air pressure. The pressure is high, away from what? From the eye, but the wind speed is low. That means when you reach here, the wind speed has been high, okay, but it starts decreasing, okay, in the eye. And then also the pressure starts to do what? To drop. So here we shall say that here at the ahead of the eye, okay, ahead of the eye, what shall we have? The wind speed is low. Wind speed is low, while, okay, while the air pressure is high. Wind speed is low, while air pressure is high. That is the first relationship between, remember we're mentioning wind speed and air pressure. So what about within the eye? What do you see here? Okay, then the wind speed declines. In the eye, the wind speed is low, but also the air pressure is also low. So low wind speed, or wind speed is dropping as the air pressure is dropping. So wind speed dropping as the air pressure. Okay, so they basically, I've answered that question. So 1.46, why is B on the sketch or as represented to be the dangerous quadrant, the left dangerous quadrant? We go back to B. Why is this one indicated to be the dangerous quadrant? Okay, it's indicated to be the dangerous quadrant because hold on, why is it referred to as the leading left quadrant or the dangerous quadrant? Because the rotating A and the direction of the system, the direction act respectively, the rotating A and the direction of the system, and the direction of the system all act in the same direction within the dangerous quadrant. All act in the same direction within the quadrant B. Okay, then how does this leading quadrant semicircle develop? So we shall say that as A or wind, as A spins around the low system, the low pressure system, they coincide or they act in the spiral to each other. They act spiral to each other in the southwest direction. That's how it develops. That's how it becomes. So the speed at which it spins and the direction at which it is going, they are all acting in the same direction. And that results into them acting strongly, resulting it to be known as a dangerous quadrant. Okay. Then we look at the next diagram. The next diagram here. So remember I told you learners, we interpret the diagram first. We refer to the sketch below. When you look at the sketch, it shows the cross section of the South African relief. It shows here on this other side we have the Atlantic Ocean. Here we have the mountain. We have the Central Plateau here. Then we have another mountain on the other side. Here we have the Indian. So if you to name this mountain here, this is going to be the Drakensberg, and this will be the Table Mountain. So this is the interior, and there is a moisture front there. There is anticyclone here and anticyclone here. So there is air that is leaving this side coming the interior, and there is air that is leaving this side coming the interior. So if you're to name this anticyclone, since this is Atlantic Ocean, this is going to be the SAHP, South Atlantic High Pressure. It's going to be the South Indian High Pressure. So remember, learners, I said you don't look at the questions immediately. You first interpret the diagram. And when you interpret the diagram, eventually you will be answering all the questions nicely. So the first question is identify the high pressure A and B. And I think I've identified them. So A is SAHP, which is the South Atlantic High Pressure, and B is HIHP, which is the South Indian High Pressure. We proceed. Which season is represented in the diagram? Obviously, the season that is represented in the diagram is summer. Why summer? I would say summer because I think it's not as, but it's summer because in the interior you can see there is rainfall. Remember, the interior experiences this kind of rainfall during summer. Somewhere here we have the cumulonimbus clouds that are responsible for this kind of rainfall. Another thing, we have the moisture front. Then you also have the converging air. Remember, air converges if it's a low pressure. So a low pressure in the interior develops only during summer. Okay. So those are reasons that can be given. However, it's not asked, but we're trying to find a way of answering the question. Okay. The next question says, define a moisture front. A moisture front, now in this case, will be defined as, sorry, it says which season. The season is here, summer. So after summer, they said give one reason. So the first reason is converging cold air and warm air in the interior. Okay, then you can give another reason here is that the CB clouds, the CB, which is the cumulonimbus clouds, you can see it here, the CB or the cumulonimbus clouds that are evident in the interior, and that is responsible for heavy rainfall. And that heavy rainfall occurs only in the interior during summer. So the CB clouds and the heavy rainfall in the interior also explains that kind of what? Of season. Okay. So the fact that warm air and cold air can intersect in the interior, it tells us that. All right. Sorry for that. The moisture front, what is a moisture front? A moisture front is a moisture boundary, or the boundary that separates the boundary that separates the cold dry air from the Atlantic Ocean, cold dry air from the Atlantic Ocean, and the warm, moist air from the Indian Ocean, So that boundary that separates the two air masses of different characteristics in the interior is known as a moisture front. Remember, these two air masses are formed of different moisture content. That's why we call it a moisture front. All right. Give two forms of precipitation that is associated with this line thunderstorm. First of all, you can see that there is heavy rainfall. Where precipitation is any form of water in the atmosphere. So we have heavy rains, and if you expect heavy rain, you can see some kind of hail within this kind of rain. So that means another form is hail. Okay, another form of precipitation is hail. The answer, the mark allocation says 2 times 1, so we have to give 2 answers. Describe the process involved in the formation of the line thunderstorm. What is the process involved in the formation of the line thunderstorm? So the moisture front already has developed. Okay. So if the moisture front has developed, what happens? So cold dry air, okay, proceeds to the interior, meeting with moist warm air. Okay, so when it meets with the moist warm air, what happens? The cold air wedges underneath, and the warm air rises along the moisture front, forming a line thunderstorm. Which comes with lightning and all that, with a line of clouds that forms on the eastern side of the thunderstorm. Okay, we go to question 2. Question 2, the first question says 2.1.1. A river and its tributaries is known as what? A river and its tributaries is known as what? We're looking at the river and its tributaries, so it means it's a system. Okay, a river and its tributaries is a system. Okay, if it had the word area or a zone, it would be a drainage basin. But since it's a river and its tributary, it becomes a system. So 2.1.2, the high-lying area that separates two drainage basins, it becomes a watershed, which is A now. Okay, the two or more rivers join. Which one is that? They join where we have a confluence. So the answer becomes what? D. Next question, refer to the sketch below and answer the questions. First question is, which kind of drainage pattern is represented here? You can see that it looks like a branch of a tree, which forms a dendritic. So that becomes B. Okay, 2.5.5, the stream order at X. We go to X. Where is X? X is here. So which stream order? So we say 1 and 1 is 2. So 1 and 1 is 2. That means 2 mixed with 2, it forms what? 3. So 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep, this is 1, so we keep 2. 1 and 1 is 2, so we keep 2 here. 1 and 1 is 2. So 1 and 1 is 2. This is 1. This is 1. Therefore, obviously, this is 3. So X is 3. And we have the third stream order there. Yes, so the answer is C. The drainage density of a drainage basin is high because it is influenced by the river flowing in the area and of and. So we come here. Obviously, we're looking at drainage density, amount of rivers that are existing on the surface of the earth. So, first of all, if it's less vegetation, that means there is more surface runoff than infiltration. So, this option must be there. So, wherever there is one, might be right. So, we are going to first see. So, do we have one here? Yes. We don't have one here. That is wrong. We don't have one here. It's wrong. So, we are remaining with C and B. Okay. So, we are remaining with C and B. So, when you look at C and B, the next one is high polar porosity. High porosity means there is more allowing water to go through. So that means if water easily goes through, it can't allow the what? The formation of high drainage density. So that one is right. So wherever you have 1 and 2 is wrong. 1 and 2. So 2 is here and 2 is here. That is wrong. But there is also another 2 here. Obviously, the answer remains high rainfall. And when you look at 5, 5 talks about high permeability, allowing easily water to go through it. So the answer is B. So the answer here becomes B, which is 1.1, 2.1.6. Okay, so 2.1.6 is answered there. Okay, then we go to this figure. We are going to use this figure to answer question 2.1.7 and 2.1.8. So here we have this figure that you can see that there are short tributaries in this kind of folded mountain. You can see this kind of folds. So that means this kind of tributaries, and we have the folded mountain, obviously tells us that it is trellis. Okay? It tells us that it is what? Trellis. Let's look at this. Tributaries of trellis drainage pattern. You see, learners, what I'm telling you. Try to interpret the diagram before you answer the question. So it is trellis there. What is the first question? Tributaries of trellis drainage pattern. Okay, so they join the main river at night at acute angle. That is wrong. It cannot be acute angle. Acute angle is less than 90 degrees. So wherever there is A is wrong. Okay, so acute angle is wrong. So 2.1.7. So they say join at 90 degrees, mainstream at right angles, which is 90 degrees. Bend 90 degrees along the course. That one we might not accept it. Then it flows away from the central place. That is wrong. So the answer is B. You can see it joins the mainstream. This is 90 degrees. You can see that. So the answer is B there. So the drainage pattern is found in this region. Which region? Inclined, jointed, uniform, folded. So folded is okay. Okay. So that means wherever you have 5 is okay. 4. So there is 4, there is 4, there is 4. So this one is wrong. Okay. They say jointed igneous rocks. Okay, jointed igneous rocks. Then uniform resistant rocks. They say uniform resistant rocks. This is the dendritic. So this one is right. Is wrong. Okay. And then talk about inclined. We say it's wrong. So the answer is 2 and what? And 5. 2 and 5 and 4. Sorry, 2 and 4. It makes it D. All right. Makes it D. Let's proceed. The next question says, we are referring to these 2 here, and we answer the questions that are there. So when you look at these 2, remember you said learners will interpret first before we look at the questions. Look at this. This drainage pattern is not uniform. This one is uniform. So when you look at this one is disrupted by a dam and by this hard rock. So there can be a waterfall here. So that means this is temporary base level and this is concave, which can refer or which can come to a permanent base level. So if it looks like this, that means there is a balance between erosion and deposition. So there is a C here, there is permanent base level of erosion. First sketch illustrates which profile? A and B. A and B illustrates that profile of the river. So the cross The cross is wrong. So this is longitudinal. Longitudinal means you see a river from the source to the mouth. The source is there, the mouth is here. The source is there, the mouth is here. So these two are longitudinal. Z answers that. So the temporary base levels of erosion is evident in which sketch? This is A. So A is Y. So Y is there. The profile of sketch B is which one? Graded or undergraded? Obviously it's graded. There is a balance here between erosion and deposition. Y is answering that. Okay. Then we say the dominant process at X. We look at X here. X is here. The dominant process at X in sketch A is dash erosion. Can't be lateral. Lateral means the sides, the river widens, becomes bigger. Edward means erodes going back to the source or the upstream. So that means the answer is Y. Because when it erodes here, going back to the source or upstream. Okay. We continue, and then when we continue, we are looking at 2.2.5. The permanent base level of erosion is in which one? A dam or a sea? A dam is in a course. So this is temporary, this is permanent. So the sea becomes Z. So in the profile, there is an equilibrium between erosion and deposition. Equilibrium between erosion and deposition, which is graded. And this is the cell. So it is B, which is Z now. Okay? Then we go, the river profile B. This B here developed due to erosion of the temporary base level or the lowering of the watershed. The answer becomes Y. So it's erosion of the temporary. So when these ones are eroded, it becomes concave. Okay. We proceed. 2.3. Refer to the photograph. The photograph there that is indicated is a valley below. So you look at this photograph. When you see this photograph, you will find out that at least it is a very sharp valley. Now, here is a narrow valley. Here, it's a V, and so on and so forth. The interlocking, the spars are there. The first question is, the valley in the photo is generally found in which stage? Obviously, it's the upper course. Can't be middle because this is a narrow valley. Okay, or a V shaped. You can see a V formed there. Identify two characteristics visible in the photo to support your answer. Which characteristic? Number one is the narrow valley. Okay, very narrow valley. Here, narrow valley. So besides the narrow valley, you can see the V-shaped valley is evident. V-shaped valley is also evident. Also, we can look at the interlocking spars. Interlocking spars. These interlocking spars that you can see there. All right. And also, we can also look at the color here of what could be the water. It is white. So that white color simply means it is in the upper course. Okay. So we can talk about the white color of the water. Okay, refer to sketches B and A, which is indicating the waterfall. So here is a waterfall there. So when you look at this, it shows how erosion will take place. But when you see there, it cannot take place at the same pace. This one, it was at the same level here. But when you check here, this one is further eaten compared to what is here, which simply means here, softer rocks, hard rocks. So if this one is soft and this one is hard, let's answer the question. What is a waterfall? A waterfall is the change in a gradient. Change in gradient, or when a river flows over hard rock down the stream. Okay, hard rock down the stream. So match YZ with the figure, and then in the sketch A with the concepts related to a hard rock and less resistant rock. So we said Y is a hard rock because you can see the rate at the speed at which it is declining is not the same speed. This one is declining. So because this one is declining faster, it is softer. This one is declining at less speed, it is hard. Therefore, here we shall say Y is a hard rock. So we say Y is hard rock and less resistant, hard rock, okay? And Z is a soft rock, which is less resistant, soft rock. So Y is a hard rock, which is resistant. Z is a soft rock, which is less resistant, okay? We continue. How does erosion in B, this B here, how does erosion in B cause the waterfall to retreat or move upstream? So we find out that at B, what happens? Um, um, how does erosion in B cause the waterfall to retreat? Cause the waterfall to retreat. Erosion at B. So we come here, retreat or move upstream. So don't forget that as this water flows over this hard rock, okay, as water flows over the hard rock, okay, we say as it flows over the hard rock, headward erosion takes place, eroding softer rocks, leaving behind, eroding softer rocks faster than the hard rocks, at Y, leading to retreat upstream, leading to retreat upstream. Okay. Refer to the sketch below on this river rejuvenation. So we have this sketch below regarding river rejuvenation. Okay, we can have the terraces. You can see the terraces here. You can see the new valley, meaning that this is the old valley. This is the new valley that is formed in the old valley. It is this river that is meandering, flowing in that direction. So there is A, there is B there. So here it is indicated that these rocks that are here are a bit softer. What is river rejuvenation? Here we say when a river gains its erosive power, or I say when the river develops the characteristics of the upper stream while it is in the lower course. State two possible causes of rejuvenation. What could cause rejuvenation? Number one is heavy rains that increases the amount of water in the river, okay, that allows it to flow faster. Then we can also say change in the gradient. So when the gradient becomes steeper, the river will erode more. Okay, we can also talk about drop in the sea level, Okay, all that assists our rejuvenation to take place. Okay, the next question says that draw a free hand cross section of from A to B of a illustrated rejuvenation. So here we look at it freehand from A to B. What do you see? You draw what you see. Here it comes down, here it comes down, you draw, it comes down, step-like feature. So what we are going to do, we draw this one. Okay, so let's see. Let's see here, it's going to be freehand cross section. They said freehand. That means they want us to indicate the shape of the rejuvenation, the shape of the rejuvenated valley. So this is the rejuvenated valley, which is the new. So we say rejuvenated valley. And then they say indicate the new valley. This is the rejuvenated valley. So the new valley is this one. New valley. When you look at the shape here, you clearly see, check here, you clearly see that here and here. So this is the new valley. So it's no longer wider, it becomes a bit narrower compared to what it was before. And then it say indicate the terraces. The terraces, the river terraces, those are the steep-like features that are left out. So these ones are the terraces. Those are the terraces. Okay. How did the river terraces illustrated above form? They form due to, so we shall say, when the river gains more energy, okay, what happens? It erodes the valley in the new valley. It erodes the old valley, forming a new valley, leaving the terraces behind, leaving the river terraces, Okay, let's go. 2.45. Explain how the illustrated landform will negatively impact on infrastructure development. That means if a valley is formed in another valley, it becomes very difficult for infrastructure to develop. So we'll find out that flooding, when now it's the landscape becomes steeper. Therefore, when it becomes steeper, what happens? It becomes difficult for infrastructure to develop. The valley becomes steeper because now a new valley is eroded in the old valley. So the landscape becomes steeper. Number two, also we can say that when it becomes steeper, it simply means that also the water flow increases, the speed increases, and when the speed increases, erosion takes place. Erosion also increases, and this increased erosion means it results into, or it makes it difficult to construct or for infrastructural development. Okay? For infrastructural development. So that is 2.4.5. We're looking at 2.5. 2.5 is an extract. It's an extract that is given about the river catchment area and river management. So you read it, talks about the river turns black after coal mine dam collapses next to the rural community in Thululwe, Mufolo's game reserve. So what happens here? Large volumes are potentially toxic coal mine waste have been spilled into the rivers flowing through communities, and Thululwe follows the game reserve. Okay, according to the US-based Union Concerned Scientists, mining and coal washing operations produce high water pollution, which can also contain toxic heavy metals such as arsenic, copper, lead, and manganese. Okay, when the Sirari Dam wall collapsed on the 24th December, the residents of the affected communities were not warned about the potential hazards until 2 weeks later. Conservation managers in the neighboring Thululwe Buffalo's Game Reserve were also led to believe that the spill was under control, only to discover pitch black water flowing through the reserve several days later. By this stage, the black water had reached the confluence of black and white Umuforo's rivers. Okay, so that is the extract. Let's see the questions. First question here for 2.5.1. What caused the river to change its color to black? Number one, it's a 1 mark question. Therefore, it is because of the toxic coal mine waste that spilled into the river. Okay? Toxic coal mine waste that spilled into the river, making the color black. So I think the answer is somewhere here in the first paragraph. So state 2 toxic heavy metals. So there is lead, there is coal, okay? It's copper. Is it coal? Is coal there? Oh, sorry. I think I haven't seen coal. Oh, coal is there. It's copper, it's coal, it's lead. So all those minerals are here. Copper, there's coal, there's lead, okay? Manganese, all those ones. The answer is just 2 marks. So I'll just take 2. Okay. What differs from the X-ray that indicates that the mining company did not disclose or make known that the pollution of the river? So you find out that somewhere here they say the residents, okay, that residents somewhere here they say when the dams collapse, when the Slurry Dam wall collapsed on 24th December, the residents of the affected community were not warned. That means they were not informed. So this one up to here about the potential hazard until 2 weeks, it answers this question 2.45. 2.45. So what could have been the negative economic impact of the non-disclosure on the community? That means if you did not disclose it to the community, and this water spilled, this toxic gas is spilled in the water, that means there would be lack of drinkable water, lack of drinkable water. So the water was polluted, so the residents were affected when they are unaware, because the water was now, the water that is there was now, the water that was available was now toxic. So here we are going to say lack of drinkable water. Drinkable water. Okay. Next one, that is in the paragraph of approximately 8 lines, describe the environmental, it's basically saying describe environmental importance of managing inflow drainage. And that means the question is 2 parts. It has got measures. We need to suggest the measures that the local community or municipality could implement to maintain the future quality of water. So we need to first of all know the negative importance. Describe the environmental importance of managing forest drainage. So if you manage the drainage system like forest, how important is it? It's going to be important environmentally because it will help to preserve or to conserve. It helps to conserve the aquatic life. So if it is well managed, it will help to conserve the aquatic life that will be found there. Okay. Number 2, also those are the habitats now that are there. Okay. It also helps to keep the water clean. If it's well managed, it helps to keep the water clean. Okay. So we said the first one, conserving the aquatic life. Number two, it helps to keep water clean. And it also helps, I'm still looking at the positive, it also helps to conserve the vegetation that grows next to the river. Remember, the question says paragraph, so it should be written in the paragraph format, despite the fact that I'm outlining it. So those are the importance of managing. If you manage it, it's okay. All this will happen. The next one is measures for the local community to implement so that in the future they can have better quality water. The first one, under the suggestions, is going to be buffering of the river. So when you buffer the river, you're protecting the river. Okay. We can also, the measure that can put in place is educating the masses about the importance of maintaining the river. The importance of maintaining the river. After educating them, you can also say measures that can put in place that punish the polluters. All those ones that are polluting the environment, punish them. You can also reward those ones who try to maintain the water sources, but you write it in the paragraph formatting. Okay. We got the last question, that is question 3. Question 3, it talks about map skills and techniques. So here it's coming from Zerast, which is northwest. Okay? The province is northwest. You read this information, is very relevant. So don't just jump it. Zerast is a commercial town situated in the northwest, which is the northwest province. Okay, it is situated in the Marico Valley, approximately 1,294 meters above the sea level. The town is 240 kilometers northwest of Johannesburg. It lies along the N4, the main road link between South Africa and Botswana. The climate in this area is characterized by short, cold, and dry winters and long, warm to hot summers. Rain is frequent during the summer months. 2 rivers flow through Zerast, that is the Klein Miliko and the Kari Strip in Zerast. Springs in Zerast. There is a natural spring at the Miliko Org. So that information is very relevant, so please don't jump it, you read it. First question that comes here is map scale that the grid reference of a spot height 13, 15 in block B4. So here I have the map. They said B4, B4. The spot height is here. They want the grid reference. Remember, we start with the latitude. Latitude is 25, but the first line is 30. That means the second line is 31. So it should be 25, 31. Because it is here, it's more or less halfway. Okay. So we come here, let's see the options. So that means this one, the longitude should be 26. If this is 4, this is 5 here, this is 6 here, and this is 7. So it should be 2607. It should be 2531. Let's go and look at those options. 25, 25, 31. So the ones that are starting with 6, 26 are wrong. So there is no way the 26 can be the latitude. Remember, we start with the latitude. Check here. The latitude is 25. So since it's 25, whatever has 26 as the first line, on the first line, is wrong. So these two are wrong. So let's come to this one. When you check this one, it says 25, 31, 26. It cannot be 25, 7. So if you come and check here, it's 25, 30, 31. So the one that starts with 31 and it starts with S and the rest is fine. So the answer is B. Okay, we go forward. They say the straight line distance from 1 in block A1 to Clipfontein on the orthophoto map is dash in kilometers. Okay, let's check on the map. Sorry for that. Let's check on the map. Question says, in block A1, on which map? Orthophoto. We come here, the orthophoto is here. Clipfontein is here. Okay, so from 1 to Clipfontein is here, but Clipfontein is not exactly located here. Clipfontein is 100 kilometers to reach it. So that means we need to measure from here to here. The answer we get, we convert it to kilometers so that we can add on to this one. So it's going to be the distance you measure from 1 to this place here, Clipfontein. Don't forget, from 1 to Clipfontein is if you measure it with centimeters, it's if you measure it with centimeters, it gives you somewhere around 4 centimeters. So 4 centimeters times 0.1, when you multiply it, 4 centimeters times 0.1, it gives you 0.4. Okay, that is the distance from here 1 to the end of the map. But from the map to reach Clipfontein is 100 kilometers. That means plus 100 kilometers. So you get 100 kilometers, 4 kilometers. And that answer is D. So this one is D. Okay. Remember, we multiply by 0.1 because the map that is given to us is orthophoto map. Okay, refer to the orthophoto map, to the topographic map. The first question says, calculate the average gradient from the spot height 1463 at F to the block in block A2 to the benchmark at G in block C2. So we come here, use the relevant information. The horizontal equivalent is 300. So the horizontal equivalent is 3000 meters, which is given. So we just need to find the vertical interval. We come here, he said spot at F, you come here, where is F? F is here, and the height at F is indicated there, which is 1463 meters, and to the spot height, to the benchmark? The question says to the benchmark, and where is the benchmark? What is the height of the benchmark? We go to that block, want to see the block. They say the block is C2 at G. When you check G here is C2, so the area is here. Okay. Sorry, it's not clear, but I'll try to zoom it out and see. Then when you zoom it out, you'll find out that the benchmark is here. Therefore, the height for that benchmark is here, which is 1183.3 meters. So what do? Come here, we say VI is equal to, so we have 1463, which is the biggest, 1463 meters, minus the lowest of the benchmark, which is 1183.3 meters. The answer you get here is 279.7 meters. That is the VI. But remember, the HE is given. We apply it in the formula. So it's going to be 279.7 meters over 3,000 meters. So divide by 279.7, also divide by 279.7. This goes into this once, over this goes into this how many times? When you put on your calculator, it will go in 10.7 and add. So the average gradient is going to be, therefore, it is 1 to 10,7. Okay, 1 to 10,7. So go ahead, use the topographic map evidence and your answer. That means we need to use the map and the answer so that we can give the reason why it will be difficult to construct a road between F and G. We come here. When you look at F, G is here, okay? And when you look at F, F is here. What do you see? We see contour lines close to each other, which means it's mountainous. So the first evidence from the map is that it will be difficult because the area is mountainous. The area is mountainous, evidenced by contour lines close to each other. Okay, so that is evidence from the topographic map. What about the answer? The answer given is 1 unit moved vertically, 1 unit vertically represents 10 meters horizontally, which means it is steep. So it becomes difficult for you to construct a road where it is steep based on the answer given. Okay. Wow, sharp. Let's proceed now. Refer to the rough cross-section that is between 2 in block A2 and 3 in block on the orthophoto map. We come here. Let's look at our orthophoto map. They say it is between 2 and 3. 2 and 3. But try to zoom it out such that I can be in position to see my features. 2. So 2 is here and 3 is here. So you can see this nature, this nature, this nature. And when you look at it roughly, this is a cross section, right? So the first one is convert the vertical scale on the cross section to the ratio scale. What is the vertical scale? It's a representative scale that is given here. So 1 centimeter represents 20 meters. So how do we change this one? This is the same as 1 over 20. And when you change this in the ratio form, it is 1 to 20. So that is the ratio form of the scale. 1 to 20. Okay. Then what does the vertical exaggeration of 5 times mean? It means geographical features are 5 times larger or exaggerated, making it visible. So it is 5 times bigger. 5 times larger or bigger or exaggerated. Okay. We go to 3.2. 3.2, its interpretation now. 3.2. So 3.2, we're referring to the block, refer to the block dash in E2, and that indicates the season of the rainfall. Dash is in this block E2 on the topographic map is indicating which season of rainfall. We got the topographic map. Okay. Topographic map is here. Therefore, when you look at this topographic map, we go to E2. E2. E2 is here. And when you check it here, what is the question? Which rivers do you see? You can see that these rivers are real broken. And they gave us a guide to say it indicates seasonal rainfall. So which rivers indicate seasonal rainfall? Of course, it can't be rough trees. Okay. which indicator here is for seasonal rainfall. Row of trees is raw. Rainy river is not seasonal, is rainfall throughout the year. Cultivated land is not answering that. The answer becomes C. Okay. So here they say refer to the graph. Here is the graph below that is indicating the average temperatures from H to what? To J. H to J. So H is here and J is here. And here they're showing the temperatures here are higher, temperatures here at J are lower. Let's see on the map. What do they say so? So H is here, which is an urban area, and J is here, which is basically having rivers and so on. Okay, so let's see the question. What do they say? Identify the human activity or the human feature that was responsible for the higher temperatures recorded at X. Here we go to X. And according to X here, X is H. So H is here. Why do we have higher temperatures here? So we have higher temperatures because that area is a built-up area. Built-up area. Or we can say urban area. Okay. Explain your answer. Explain your answer. So we say let's try the human-made picture, built up, or a city built up area. Yes. Explain your answer in 3.2. So 3.2, the urban infrastructure or the built up area. Okay? Buildings, here we say buildings, built up, the human feature is a built up area. The human feature here, buildings. So human feature here, buildings that are responsible for the higher temperature. So the high buildings. The high buildings, which is the built up. So we say buildings absorb heat, making the city hotter. Buildings absorb heat, making the city to have higher temperatures. Okay, identify the natural feature that resulted into lower temperatures at Y. Let's go to Y here. Let's go to Y. Come on, Y. Y. Which natural feature? So identify the natural feature. Identify the natural feature. Identify the natural feature. Identify, the question says, identify a natural feature that resulted in lower temperatures at Y. When you come here at J is where Y is. Which natural feature is there? You can see when you see this, there's a river there, isn't it? River, it helps to cool the environment. It's also that green vegetation, this protected area, which makes it the green vegetation. Okay, so here, the natural feature here is the perennial river. The perennial river. Okay. Next thing is which sketch below represents the slope from 4 in block C1 to 5 in block B1 on the orthophoto map. So we come to the orthophoto map here. Come to the orthophoto map here. The orthophoto map here, we are looking at 4 and 5. 4 from 4 to 5. This is a higher area, it's a lower area. So the contour lines are increasing going upwards. When the contour lines are increasing going upwards, it tells us A. Okay. Refer to the orthophoto map. How did the topography or relief of the area favor the location of the rifle range? Let's go to the rifle range. The rifle range is here. It's mountainous, it's mountainous, it's mountainous, it's mountainous. What does the rifle range, what is it used for? This is used for people who learn or train how to shoot. So if you're shooting, learning how to shoot, it's the mountain is favoring. Okay, the relief in the area favors because the bullets end in the mountains, or the mountains, and say the mountain shields the areas around. The mountain shields the areas around. The mountains shield the areas around. Okay. The mountain shields the area around. That is 3.26. 3.27. Describe two factors on the topographic map that limited the pollution of the Climatology dam. You come here, where is the dam? The dam is here. Which two? But the question says two factors on the topographic that limited pollution. What limited pollution there? First of all, the first factor that limits pollution is that the dam is located in between mountains. Okay, it's in between mountains, number one. Number two, it's close or it's located next to the protected area. So here you can see this is a protected area, and when you look at the nature of the relief around, it's mountainous. It's mountainous. So here we shall say the two factors is located in the protected area. So no just accessibility at any time, protected area. Number two, the mountainous nature around. Around the dam. Around the dam. That means it limits people's settlement. Therefore, there will be less pollution in the area or on the dam. Look at the last section. The last section says, which one of the following is a standardized point symbol? Point symbol. Obviously, that is found on the topographic map. This is not a point. That is a polygon. C is a line feature, and this road is a line feature. The only point feature is B. Therefore, the answer here is B. That is the only point feature. Okay. And when you check here, let's go to the topographic map and look for it. When you go to the topographic map and look for it, it is somewhere here. Okay. That is where we have our point feature, which is a monument. A monument is a point feature. Okay. Give one attribute and identify the alpha numeric block on the topographic map on which the point symbol is located. We go back to the map. Alphanumeric. What is the alphabet? It's located at alphabet C. And then what is the numeric? The numeric is 3. So it is C3. So here is C3. Okay? Then the last question, it says, give one attribute data of the point symbol on that answer, evident on the topographic map. You come here, this point symbol has got a name. What is the name? The name here is Graphendiferous. Okay, so you write it here, Graphendiferous codes. So 1820 to 1891. Okay, the last section of the paper says, identify the GIS component A. GIS component A. Where is A? A is here, and therefore, that is, we call it people. Okay, the component is people. It's an individual, GIS specialist. People, person, or GIS specialist, whatever. Give one reason why GIS component, answer the question, is important. Why or the GIS component in that question above is important to interpret and analyze data. Okay. Okay. Also helps in data application. Okay. Data integration is illustrated in the sketch. Give one reason to support your answer. Okay. Several features are merged on the same paper or area. So you can see this one was separated, and then there are some lines on this map. So they are all merged and they're all appearing here. So you can see this one was separated from this, and later it's put in one area. That is in integration, trying to interpret or to put the data together. You integrate it, you add it onto. So the features are all merged in the same area or in the same part. They are put together, they are integrated together. So that marks the end of the paper. Thank you for listening. See you when you're doing paper 2. Bye.